In many applications, we need to find out the coefficient of a component coming from a binomial expansion. So here is an example of computing the coefficient of a given similar problem. So we have the product of two binomial expansions, 5b to the 7 minus 2a cubed to the power 13, the whole thing, product of that with square root of 7x cubed minus 3y, the whole thing to the power 19. Apparently, one of the components coming out of this whole product of two given binomial expansion is b to the 77 times a to the 6 times y to the 15 times x to the 6. The question is how to compute the coefficient of this component. To do that, um, let's first figure out whether this is a valid component that can result by doing the product of these two binomial expansion. To do that, it's a simple process. So what we're going to do is we're going to rewrite b to the 77, a to the 6 in the form of b to the power 7, the whole thing to the power 11, and times a cubed to the power 2. We can rewrite it that way. Well, the only reason we are doing this is because effectively you can see that 11 plus 2 is equal to 13. And that is in line with this 13 that you see here. So it validates the fact that this can be a factor resulting from this first binomial expansion that is observed here. So that really can result in this portion of the component that we are looking for. So it's a valid component. Um, Now, therefore, from this, we can just say that b to the 77, a to the 6 is a valid term of 5b to the 7 minus 2a cubed, the whole thing to the power 13. Okay, great. So what we're going to do is um, we're going to figure out how to do that. Obviously, it means we have to do a 13 choose 3, 13 choose 2 to get the a to the 3, the whole thing to the power 2 component. So the binomial term would be 13 choose 2. Basically, it means you are multiplying this parentheses by itself 13 times. Out of those 13 things that are multiplied together, 2 of the parentheses are supposed to give us a to the power 3 component, so that as a result we get a to the 6 coming out of it. That's why we have to explore 13 choose 2. We have 13 objects, which are the 13 parentheses. Our desire is to choose 2 out of those 13. And then as a result of that, we are getting this component, minus 2a cubed, this one, twice. So that would be to the power 2. Okay. And then we are getting the rest of the 11 parentheses giving us 5b to the power 7, the first component, to the power 11. As a result of this, we're going to get 13 choose 2. We have minus 2 to the power 2 coming out, so you have times 4. And then aside from that, we have 5 to the power 11 coming out of this thing, so it's going to be 5 to the power 11. And then what else we have is a to the power 6, so it's going to be a to the power 6. And finally, we have b to the power 77. Okay, so this is the component that we were looking for. And this is the corresponding coefficient behind that component. Um, okay, so let's keep this in mind for now, and let's move on to the next one. So this would be basically the binomial coefficient. Okay, right. So this would be our binomial coefficient for this term. And now for the next one, which is this term, we also have to do the same check. So what we're going to do is we're going to say, fine, uh, it is y to the power 15, x to the power 6. We're going to rewrite it as y to the power 15, and we can rewrite x to the power 6 in this form: square root of x cubed to the power 4. That obviously results in x to the power 6. And now what we can see is this: 15 plus 4 is equal to 19, which is exactly in line with the power of the second binomial expansion even here. So this means y to the 15 x to the power 6 is also a valid term of this binomial expansion, the second one, square root of 7x cubed minus 3y to the power 19. So it's a valid term, and because it's a valid term, then we can figure out the binomial coefficient and binomial term. So it's binomial term that result in these guys would be, now what we are doing is we are effectively selecting for there 19. This effectively this binomial term is multiplied by itself 19 times because of power 19. Out of the 19 parentheses, out of 4 of them, we want the square root of x cubed to come out. So we need to do a 19 choose 4. So that's why we have 19 choose 4. And then the corresponding component is the square root of 7x to the power 3. So we have square root of 7x cubed to the power 4. And then the remaining ones are 15 parentheses that are just giving us minus 3y to the power 15. What we get from this is 19 choose 4. You can see that we get from a square root of 7 to the power 4, we get 7 to the power 2, which is 49. And from this component, we get minus 3 to the power 15. So I can write it down as minus 3 to the power 15. And the rest of the component would be, of course, the square root of x cubed to the power 4 is x to the power 6. And here we get y to the power 15. Okay, so this is the term that we were interested in because that's the term that we were looking for from the given problem definition. And here you have the corresponding binomial coefficient. Okay, now the whole thing is basically product of these two, which is one of the terms that result from the product of these two binomial expansion. So we would say, let me just change the color. So we would say product of the above two binomial coefficient okay, would be then there's a negative sign because we have because we have the minus negative, we have the negative 3 to the power 15 here, and that's raised to the odd power, so negative would come out. So you would have negative, and then you would have 19 choose 4. That's what we have here. And then we have 13 choose 2. That's what we have here. And then we have 2 to the 2, which is our 4 here. And then we have 3 to the 5, 3 to the 15, which is here. And we have 5 to the 11, which is the component we have here. And then finally we have 7 to the 2. So this is the final answer we were looking for. I hope that this is helpful in illustrating how to compute the binomial coefficient.